All right, so we're going to do summation notation. We skipped this, and I just went and asked Algebra 2 teachers, and it sounds like because of coronavirus, you barely touched on this stuff last year. So this is the Greek letter sigma, this kind of funky looking E thing. It's actually called a sigma notation, and that is an S in Greek, which in this case, sigma notation means it's going to be a sum. So this thing down here, the I is called the index, and it can be any variable. In this case, a lot of times they let it be I, it can be other things. The 1 is called the lower bound. In other words, that's the first number you're going to plug in. And then n is your upper bound. That's the last number you plug in. And you're plugging in the integers from 1 to whatever n is. So if you look at this is the summation of I equals 1 to n of a sub I. So there's your I, and the first thing you do is you plug your 1 in, your first number, and that's going to be the first value. And then you add, because it's summation. Then you plug the next value after 1 in, which is 2. And then you plug the next value in, which is 3, and you keep going until you get to the top number. So if we look at this notation, the summation of I equals 1 to 6 of I, that's going to equal, and the first thing we're going to do is plug in 1, then we're going to plug in 2, then we're going to plug in 3, then we're going to plug in 4, then we're going to plug in 5, and last we're going to plug in 6. So if I get this summation, this is going to be 21, I believe, if we add all those up. Now over here, we could do it again, except now we're going to have to do 12 numbers, and I don't really want to do 12. And if you notice, it's got a little calculator symbol here. Our calculators happen to have this on them, so I'm going to bring my camera over here to you with my calculator on it. And I'm going to show you where you can plug this in on your calculator. So I turn this thing on. And I want summation notation. So I'm going to hit mode. Nope, I'm sorry, not mode. I want to hit math. And I'm going to arrow up. And if you look at 0 right there, that says summation with the sigma. So we're going to come up here and we're going to type in or hit enter there. You could have also hit 0 and would have plugged that in. Now I could put an I in there, but because I'm going to use X, because my X value is really fast, is right there. I'm going to hit X equals 1 to 12. And then I'm going to come over here, and you look to the right there on the screen, B says J squared. I guess they use J. I could have put a J there, but since I used X here, I need to use X there. So I'm going to make this X squared. And then I'm going to hit enter. Oh, that's not a 1, is it? That's a 3. My bad. I got to go back and change that to a 3. Because the first number we were plugging in is a 3. I'm going to plug a 3 in there and hit enter. And that sum would be 645. So if I started and I took over here to the right and put 3 squared plus 4 squared plus 5 squared all the way up to 12 squared and added all those together, I would get 645. But I hope you see using your calculator would be way, way faster. And that we're going to use that calculator to check some stuff later on. And then down here are properties of summation notation, which is something you were supposed to have in Algebra 2. And pre-cal, but I'm kind of thinking we didn't get to any of this because of coronavirus. So the first one is this K stands for any constant. So just like integrals that we've already done, you can take your constant and stick it out in front and have K times the summation of this, and that will give you the same thing. So like if there would have been a 2 here in front of this, I could have put a 2 out there in front and done some summation notation of J equals 3 to 12 of J squared, and then that would have been 2 times this answer, and I think it was 645, and I've taken 2 times 645, that would have been the answer to that one. Another property is if you got a sum or difference in here, this is a difference, if you got a sum or difference, you can break this up into 2 different summation problems. You do the summation of the first thing plus the summation of the second. If you got a minus, you can have this first thing minus the summation of the second thing. So this is just properties of how you can change some summation problems to make them easier to do. All right, and then this next thing is Gauss's stuff. He came up with these summation formulas. And then this one says if you've got a constant C here, this is kind of a shortcut thing. But if you got a constant C, like if I said the sum of equals 1 to n, well, let's say it was I equals 1 to 20. And this number was 3 here. So instead of doing 3 plus 3 plus 3 plus 3, because there's no number to change to put 1 in here, if you just take the 3 times the 20, that summation would be 60 because you have 20 3's. So these are kind of shortcuts. And then there's another one that is a shortcut that would have worked with this one up here, is that you could rewrite if you have just a variable here that it's n, in other words, that top number times n plus 1 over 2. And that's kind of how I did this one right here, is that if you take this number plus this number, or times, sorry, not this number, but this 6. So in other words, if this were the 6 that it is up here, and you take 6 times 6 plus 1, that's 42 divided by 2, that's that same 21 you get right there. So these are little shortcuts. I squared is this formula. And these formulas get more and more complex, and you're supposed to actually already have these memorized. So this, whenever you have an I squared, it's n times n plus 1 times 2n plus 1 all over 6. And then if you have an I cubed, it's n squared times n plus 1 squared all over 4. And again, n is whatever the top number is. So you can use a combination of these things to make your problems a lot faster than they are. But with our calculators, you can also do that. So we want to evaluate this thing. So we're going to evaluate this by hand, and then we're going to use our calculator to check it. So one of my formulas says I can split this up into 3 summation notations. So I can do the summation as I equals 1 to 10 of I squared plus, not plus, but minus, because that's a minus, minus the summation of I equals 1 to 10 of I plus the summation of I equals 1 to 10 of 4. Now what I'm going to do here is I'm going to go back and use some of that old material that we just looked at over here, down here at the bottom. So that first one says I squared. So I'm going to use this formula right here. And I'm going to go back over here. And this formula for this is n times n plus 1 times 2n plus 1 all over 6. So if I take that n, which is this 10 up here, and I plug that into these n's, this part will be 10 plus times 10 plus 1 times 2 times 10 plus 1 all over 6, and then minus. Then I got this I here. So again, we go back over here, and the formula for I is this one right here. I'm going to take n times n plus 1 all over 2. So this part right here is n times n plus 1 all over 2. And n is your upper bound, which is still 10. So this is going to be minus 10 times 10 plus 1 all over 2. And then plus, now that's a constant. So you go back over here, and your constant one is this one right here. So you take your constant. Again, this is Cn, and the n is 10, C is 4, so this would be 4 times 10. And now we just want to simplify all this. Well, this 6 will reduce with that 21 to a 7 and a 2, and then that 2 reduces with that 10 to a 5. So we get 5 times 11 times 7. So 5 times 11 times 7, 5 times 11 is 55, times 7 is going to be 5 carry 3, 35, and 3 is 38. So this part is 385. Minus this is, I'm going to reduce this to a 5, and 5 times 11 is minus 55. And then I got plus 40, so I'd probably take these two and get negative 15 and subtract 15 from this, and this would be 370. So this whole summation right here equals 370. So I'm going to show you that. We're going to check that on our calculator just to show you that it's the same thing. Let me get my calculator up here. I'm going to move that down a little bit so you can see that. I'm going to type that thing in there and show you that I get the same answer. So I'm going to turn this thing on. I'm going to hit math, and 0 will give me the summation, and I'm going to do x instead of I because it's faster. And I've got 1 to 10, so I'm going to hit 1 there, 10 there, and then I'm going to come over here and type that whole thing in there. And I'm using x's, remember, so it's x squared minus x plus 4. And I hit enter, and there's the same 370 I got by hand. So you can use your calculator to check those. Okay, so you're supposed to try to memorize those summation things. Now I'm going to come down here to this example 3. And what I want to do is I want to rewrite these, and instead of writing them out in this long form, I'm going back to this form. So I'm going to take from this form and go back into summation form, because you can use this to write long summations into a smaller formula. So first of all, we're adding different things. So I'm going to do I equal something to something of a formula. So what I want to do up here is see what is changing from each one. What is changing? If I look, the numbers that's changing is this last number. Okay, and it looks like we're changing from 1, then we go to 2, then we go to 3. So this is going to be my lower bound, because that's the first thing we're plugging into what's changing. And then this number here, this 15, is going to be my upper bound, because that's the last number I plugged in. And then everything stays the same except this thing I underlined. So this is where the I goes. So this will be how I would write this formula in summation notation. Again, now this is a longer thing. There's one sum right there. So I'm going to look at this whole thing, and then there's another plus sign there. I'm going to look at that thing, and here's another plus sign here. And I'm going to look at this, and I'm looking to see what's changing up here. So if you look, you got 1 minus, and there's a 2 over n minus 1, and then this is a 4 over n minus 1, and then this is 6. So the numbers that are changing are these things. And this last one gives me a hint as to what's happening. So if you look, if I take 2 times 1, don't I get 2? So the first thing I want to get is this one. And then if I take 2 times, I plug in 2 here, that gives me a 4. And if I plug in a 3, I get a 6, and we keep going. But they're saying the last thing I'm plugging in is n. I'm not plugging a number in, I'm plugging n in. So this is going to be an n up here. And the first number I'm plugging in is a 1, because we said 1 times 2 gives me this. So then I'm going to have 1 minus parenthesis. And all I'm doing is looking at this, and kind of looking at this, really, this one. And I'm going to put up here, but instead of n, since I've got an I here, this would be 2i right there, because this has an n in it, because that's the last one, and that is when I plug in here. And I put that over n, because if you look, all these have n in the bottom. Okay, and then I got a minus 1 in parentheses, and this whole thing is squared. You see a little square on each one, so I got to put a square here, and then every one of them has a 2 over n at the end. So this right here is how I would write the summation notation for those two problems. So the further we go here, the harder this is going to get, and we get to 7 and 8, they're going to be the hardest probably. So I'm going to stop there, and I'm going to do another video here in a minute.